High in the Andes, at almost 13,000 feet, blocks weighing up to 200 tons lock so tightly together that a razor blade snaps in the seam. Official histories credit these megalithic walls to stone hammers, sweat, and human will. Yet no modern builder has matched this kind of impossible precision, not even with cutting-edge tools. So what did the ancient engineers of Peru really know, and why does every standard explanation collapse under close scrutiny? The paradox behind these stones isn't just a riddle. It could change what we think we know about humanity's true past. At nearly 13,000 feet above sea level, the air thins and the world narrows to stone, sky, and silence. Here, the walls of Sacsayhuamán rise in colossal terraces, their faces carved from boulders that dwarf any passerby. One block, weighing close to 200 tons, anchors the corner, its mass greater than a fully loaded Boeing 747. The stones are not uniform rectangles, but irregular polygons, some with over a dozen sides, each one shaped to interlock with its neighbors in a puzzle so precise that the seams vanish from view. No mortar binds these giants. Instead, they press against each other with such accuracy that a modern razor blade pressed into the joint simply snaps. Engineers who have measured the fit describe tolerances that defy belief. Joints so tight, even today's diamond saws would struggle to replicate them across such uneven geometry. The surface of each stone flows organically, curving and nestling into its neighbors, as if the rock had once been soft clay molded by unseen hands. The largest blocks stand over 9 meters tall, 5 meters wide, and 4 meters thick, each one weighing as much as a diesel locomotive. These walls stretch for hundreds of meters, zigzagging in massive terraces that look as if they were designed to withstand the shaking of the earth itself. The scale is staggering, but it's the silent perfection of the fit, the invisible seams, the absence of any binding material, the refusal of even a whisper of air to slip between the stones, that transforms these ruins from mere relics into an engineering riddle. Every attempt to measure, to probe, to explain only deepens the mystery. Faced with such impossible stonework, the question is not just how these walls were built, whether we truly understand the minds and methods of those who shaped them. The story told in most textbooks begins in the 15th century with the rise of the Inca Empire under Pachacutec. Chroniclers like Pedro Sancho, writing in the wake of the Spanish conquest, described how the NCA organized thousands of workers to build the Great Walls above Cusco. The official explanation holds that these feats were achieved through sheer manpower, a system called mita, a labor tax that mobilized entire communities for state projects. Teams of men, armed with hammerstones and wooden levers, would quarry massive limestone and andesite blocks, sometimes from distances of over 20 kilometers. The stones were dragged, rolled, or slid on beds of logs and earth, inch by inch, up steep mountain slopes. Once on site, workers shaped each block by pounding with stone tools and grinding surfaces with sand and water, fitting them together through repeated testing and adjustment. According to this view, the Inca's success lay not in secret technology, but in relentless labor, discipline, and empirical knowledge passed down through generations. Dr. Maria Alvarez, an archaeologist at the National University of San Marcos, describes the process as a triumph of organization rather than machinery. What we see, she explains, is a society that could command the efforts of tens of thousands, orchestrating logistics and craftsmanship on a scale unmatched in the Americas. She points to evidence of percussion marks on unfinished stones and the use of wooden wedges to split rock along natural fractures. The mite system, she notes, allowed the Inca to sustain multi-year construction campaigns, with each community contributing workers as a civic duty. Chroniclers recorded that after the conquest, the Spanish marveled at the discipline and coordination needed to move stones weighing more than 100 tons, sometimes across rivers and up to the very edge of the sky. Yet, even as the mainstream narrative accounts for the scale and organization, it leaves questions lingering at the edges. The official story explains the who and the when, but the how, the exact methods by which such precision was achieved, remain a subject of debate. The tools found at quarry sites are simple, the scars on the stones rough and unmistakable, but the final fit, the seamless joints, and the resilience of the structures continue to challenge the limits of this explanation. Laser scanners sweep across the ancient walls, collecting millions of data points in a matter of minutes. The resulting models reveal something that measuring tapes and calipers could never capture. The stones do not just fit together, they wrap and lock in 3 dimensions, each surface tracing a unique, undulating path that mirrors its neighbor. One block at Sacsayhuamán displays 12 distinct angles, its faces converging so tightly that the gap between stones measures less than half a millimeter, thinner than a human fingernail. Survey teams from the University of Tokyo and MIT have mapped these joints with micrometer precision, confirming that the fit is not an illusion of age or weathering. The seams run straight and true, sometimes curving in gentle arcs, but always maintaining a uniform closeness impossible to achieve by chance or rough adjustment. The geometry is more complex than simple stacking. Each stone is a polygon, some with as many as 12 or even 14 sides, each one shaped to nestle perfectly into its neighbors. The blocks are not flat, they bulge, dip, and curve, creating a puzzle where every piece is unique. Modern engineers, used to right angles and standard dimensions, find themselves at a loss to explain how these compound surfaces were planned and executed. Attempts to recreate the effect with modern tools, diamond-tipped saws, and laser-guided cutters have produced joints with visible gaps, especially when scaling up to blocks weighing dozens of tons. The ancient masons, working without written plans or digital models, achieved a consistency that rivals the tolerances of aerospace manufacturing. The full extent of this craftsmanship only becomes clear under the scrutiny of 3D analysis. The stones do not just fit on the surface, the precision extends deep into the joints, with interlocking ridges and hollows that distribute weight and lock the blocks in place. This is not the work of trial and error, but of a system, one that quantifies, measures, and executes with a measurement accuracy that remains unmatched. For every theory that relies on brute force or endless patience, the geometry itself answers back. This is not just hard labor, but an art of measurement and design that still challenges the limits of modern understanding. Modern engineering labs have tried to match the stonework found at Sacsayhuamán and Ollantaytambo, bringing in diamond-tipped saws, computer-guided cutters, and teams of specialists. Yet when tasked with carving and fitting multi-ton blocks into organic, interlocking shapes, the results fall short. CNC machines, used to craft aerospace components, struggle to maintain a uniform gap across irregular curving surfaces when the stones reach the size and complexity of those in Peru. The tolerances achieved by ancient masons remain out of reach, even for factories that build jet engines and satellites. Civil engineer Carlos Reyes, who spent years studying both the ruins and the tools available today, offers a blunt assessment. If you gave a modern construction crew the same task, with only hand tools, no steel, and no electricity, it would take months just to shape a single block to this standard of fit. And even then, you'd likely never get the joint as tight as what's already there. Attempts to replicate the seamless joints on site have resulted in visible gaps, chipped corners, and uneven contact. Even with diamond blades and laser measurement, the organic curves and compound angles of the original stones proved nearly impossible to reproduce at scale. Modern masons can cut straight lines and flat surfaces, but the ancient builders shaped each stone to wrap and flow around its neighbors, locking them in place without relying on gravity alone. The tools found at the ancient quarries, hammerstones, wooden levers, sand for grinding, cannot explain the speed or precision implied by the finished walls. In controlled experiments, shaping a single surface to fit another with this level of accuracy takes days, sometimes weeks, even with modern abrasives. Reyes estimates that using only traditional tools, a modern crew would spend months on a single block. This gap between what's theoretically possible and what was actually achieved raises a new question. Even if the stones could be shaped in place, how were they moved across such unforgiving terrain? The mystery deepens, not just in the cutting, but in the moving. Between the quarry and the walls of Sacsayhuamán lies a journey that defies easy explanation, an impossible trek. The largest stones, some weighing nearly 200 tons, were sourced from quarries over 5 kilometers away, with the heaviest blocks traced to sites more than 30 kilometers from the plateau. The route is anything but forgiving: steep mountain slopes, ravines, and the thin air of the Andes, where oxygen levels drop to about 60% of what's found at sea level. Even the strongest laborers would have faced exhaustion and altitude sickness with every step. Dr. Lucia Perez, a geologist specializing in trace element sourcing, has mapped the chemical signatures of the stones. Her fieldwork confirms that the blocks at Sacsayhuamán match outcrops on distant ridges, not the hills immediately surrounding Cusco. This means the stones were not simply rolled downhill, but hauled across valleys, over rivers, and up switchbacks that climb hundreds of meters in elevation. No evidence of ancient roads wide enough for such cargo remains. There are no ruts from wheeled carts, no scars from sleds dragged over rock, and no remnants of ramps or scaffolding big enough to support stones of this size. The MTA had no draft animals capable of moving these weights. Llamas could carry only a fraction, and there is no sign that larger beasts were ever domesticated in these mountains. Physiological studies conducted at altitude show that a person's capacity for sustained heavy labor drops by nearly half compared to sea level. For construction crews working at 13,000 feet, the challenge would have been immense. The logistics of organizing teams to move stones weighing more than a fully loaded locomotive over terrain where even walking is a struggle remains unsolved. Dr. Perez's measurements suggest that, in some cases, the stones were shaped at the quarry, then transported in finished form, raising the stakes even higher. Any slip, any miscalculation, and months of labor could be lost to a shattered block at the bottom of a ravine. The physical reality of moving these stones forces a new question. What kind of structural genius or unknown method could overcome such odds? Professor Alejandro Vargas stands before the battered walls of Sacsayhuamán, running his hand along the inward-sloping face. The angle, he explains, is no accident. Each terrace leans into the hillside at a calculated batter, typically between 5 and 15 degrees. This subtle tilt transforms the wall into a living structure, one that absorbs and channels the violent shocks of an earthquake rather than resisting them head-on. When seismic waves strike, the stones do not lock rigidly in place. Instead, they move just slightly, almost imperceptibly, allowing the entire wall to flex and sway. Locals call them dancing stones. During the massive earthquake of 1650, colonial buildings in Cusco crumbled, but the ancient walls shifted, realigned, and settled back without collapse. The secret lies not only in the batter, but in the intricate interlocking of each stone, which distributes the load across multiple angles and planes. Stress is never allowed to concentrate in a single spot. Instead, it spreads out, dissipating energy throughout the structure. Even the joints, invisible to the naked eye, are shaped to lock the stones together in 3 dimensions, creating a base isolated effect centuries before the concept existed in modern engineering. Vargas points to weathering patterns that tell a deeper story. The oldest stones, forming the core of the walls, show a patina and erosion distinct from the upper layers. Radiocarbon dating of surrounding soils and lichen growth suggests these foundational blocks may be centuries older than the Inca themselves. The implication is stark. The most advanced engineering belongs to the earliest phase. Later additions, built atop the ancient core, lack the same inward tilt and show simpler, less resilient construction. In the Andes, where the earth never truly rests, this design is not just clever, it is essential. The builders understood the land's restlessness and responded with walls that move with the mountain, not against it. The sophistication of this system, hidden in plain sight, suggests a knowledge of seismic forces and structural dynamics far ahead of its time. Ollantaytambo stands nearly 300 kilometers from Sacsayhuamán. Yet its walls display the same uncanny stonework, massive andesite blocks, some over 70 tons, locked together in seamless, irregular patterns. The trapezoidal doorways and terraces echo the same design logic: stones shaped to nest, not stack, and joints that refuse even the thinnest blade. Dr. Elena Torres, a geospatial archaeologist, points to recent LiDAR surveys that have transformed the map of the Sacred Valley. These scans reveal that sites like Ollantaytambo, Sacsayhuamán, and even distant nodes such as Pumapunku in Bolivia are not isolated marvels. They form a network of more than 30 major sites, each sharing the same geometric principles and construction techniques. The alignments are not random. Some sites sit along straight lines, stretching for miles, while others cluster at natural crossroads or points of astronomical significance. Torres notes that the pattern repeats across the high Andes, with each node displaying a distinct signature of precision masonry, polygonal blocks, seamless joints, and foundation systems built to last through centuries of earthquakes. The evidence points to a shared blueprint, a system of knowledge that spanned cultures and landscapes, challenging the idea that these feats were one-off achievements or local anomalies. Magnetic surveys in the high Andes have recorded subtle but persistent anomalies concentrated around the foundations of the oldest megalithic sites. Instruments register shifts in the Earth's field that defy easy geological explanation, as if the stones themselves hold a memory of forces beyond simple gravity and mass. Some researchers argue these readings are artifacts, quirks of the local bedrock. Others, like Dr. Elena Torres, caution that such patterns deserve closer scrutiny. She points to the clustering of anomalies along the same lines as the ancient walls, lines that, in some cases, run for miles and connect sites separated by entire valleys. The more the data accumulates, the less the story fits into a straight line of progress. The evidence does not suggest a simple arc of invention, improvement, and mastery. Instead, it hints at lost knowledge, at techniques and understandings that may have peaked and then vanished, leaving only the silent stones as witnesses. Torres's final word lingers in the air. We are looking at a civilization that knew things we have not yet rediscovered. The question is not just how they built, but why their knowledge seems to have faded, why the greatest precision appears at the oldest layers, with later generations struggling to match it. The ruins do not offer closure. They press back with their own questions, challenging the idea that human progress moves only forward and leaving the timeline of technology open to doubt. While laser mapping and modern engineering still struggle to replicate these megalithic feats, the stones of Peru remain unyielding evidence that human innovation can far exceed our expectations. As new technology exposes limits in our own understanding, the real mystery now is how much ancient knowledge we've lost. History isn't set in stone, it's still being carved. What do you think we're missing? Share your thoughts below.